Hi everybody, Mr. Rubo here. We are continuing 2.13 today. Is exponentials and log equations and inequalities. So previously we've solved inequalities of polynomials and rational functions. To do this, we found x coordinates where the functions had zeros, wholes, or vertical asymptotes, and then used a sign chart to determine the intervals where the function was positive and negative. We can solve inequalities involving exponentials and logs the same way, except it is much simpler when working with exponentials and logs, believe it or not. All right. So with this, what we're going to do is we have f of x equals this log x squared minus 4x plus 7 minus log x plus 3. We're trying to find all the values of x for which f of x is greater than 0. So what we want to do here is we want to look at the function. And so we're going to look at the domain here initially. Well, I'm going to look at this guy and x squared minus 4x plus 7, and it has to be positive. Okay, that's because it's a log, we know this restriction has to be true. We also know that x plus 3 has to be positive. Okay, which means this one's nice. We get x is greater than -3. This one does require a little bit of work. I will tell you it does not factor. You would do some quadratic formula or possibly even graph it. And just so we're all good, if you were to graph this, it's always positive. So this one, it's always going to be true. So we don't have to worry about this. So always positive. Okay. So now what we're going to do is we're going to look at this original equation, this original function, and say it's got to be greater than 0, but we're also going to start simplifying it. So what I mean by that is we have the subtraction, so let's go ahead and write it as one term. So we're going to say the numerator over the denominator. Okay. Now greater than 0. All right. So remember, our base here is 10. So now what we're going to do, we have an exponential, we have a log, but it's got a rational function on the inside. We know how to deal with rationals. So what we're going to do here is we're going to do a lot of algebra, but the algebra is nothing too bad. Okay. So we're going to want to switch this to an exponential because we don't like having our x's confined inside of the log. So we're going to say x squared minus 4x plus 7 over x plus 3 has got to be greater than 10 to the 0. So we just did the same thing we've done previously, but this time we have just the inequality symbol. Okay, so we're just changing to an exponential. Well, the thing is 10 to the 0 is 1, so I'm going to move that over. And again, this is all algebra at this point. Oh no, my stylus doesn't want to write. There we go. X squared minus 4x plus 7 over x plus 3. Well, minus 1 greater than 0, because we always got to compare to 0. Now, we got to get a common denominator, so that means this 1 was going to become x plus 3 over x plus 3. Okay, and again, that's because we needed a common denominator. And what's going to happen in something that we couldn't deal with before, it's going to simplify and work out really nicely for us. So we're going to go ahead and say, okay, x squared minus 5x, 7 minus 3 is 4. And the denominator is the denominator. And look at this, we end up getting that our numerator now factors. And this is something we've been solving for a long, long time at this point. Well, we're going to go ahead and do a sign chart. So let me do it over here. We have three things. We have -3, +1, and +4. At -3, we're undefined. Okay, So this is where we start plugging in values. Well, the nice thing is we don't have to plug in anything over here because x has to be bigger than 3. So we actually don't have to plug in like -4 because of the fact of our original domain restriction. That's why we checked it at the beginning. So now we're going to go ahead and we're going to plug in something from -3 to 1. And you just have to plug it into this rational function. So I'm going to plug in 0. So you get negative, negative, positive. So two negatives mean you get a positive. Oh no, my stylus does not like to work right now. There we go, positive answer. Then, so that was x equals 0. Let's do x equals 2, because that's between 1 and 4. When you do 2, you get -2, +1, +5. So 1 negative means the whole thing is negative. And then here I'm going to plug in x equals 5. And again, same idea. Everything becomes positive, which means we have everything positive. So if I use my sign chart, my answer for this guy is going to be from -3 to 1. 1 is going to be included. I'm sorry, nothing's included because it's greater than 0. So we're looking for positive answers. So -3 to 1, and then 4 to infinity, just like we had done before. Okay. So yeah, there you go. There's our log inequality, something that rationally we would have issues solving this because of the fact that we have some imaginary solutions, but it ends up, when we do some log properties, we end up making it a lot simpler. So that's what I meant by it would be simpler. All right. All right. Well, thanks for watching and have a good day.